Hey everyone, and welcome to the next session on TCS Digital. This is again a live session that's going to be on YouTube. We have a complete playlist for you to check it out if you have missed out any of the previous videos. So, we're going to be going through a lot of TCS Digital problems that you can generally expect in a digital coding round interviews. So in the last session, we were going through this particular problem called Lapindrome, where we are trying to find out by considering a string, like let's say something like this, is the first half of the string having same characters as the second half of the string but in different order. This is what we were going through, and we have done the same code in C++ and Java in the last session. We just are gonna convert it to Python in today's session, and once we're done with it, we'll immediately go for another very important problem that is called T9 keyboard problem, or T9 keypad problem as it's often called. So let's go ahead and quickly convert the current code into Python. And just to point out, as always, this is a live session by Quant Masters on YouTube. So today, if you guys have any queries on the programs that you're doing, you can just put it up on live chat, and I will ensure, or we will ensure, to answer it as much as possible so that you can get to know it well. Now, let's go ahead from here. So we have already completed the code in, let's say, C++ and Java. We just need to write the same code over in Python. So we're just going to begin very quickly. So the idea is to figure out if a string is palindrome. So let's first read the string. I'm just going to take something like str. And again, since so many of you are joining up right now, just to point out, the moment we are done with this particular problem, we'll immediately be going for a very important problem, that is T9 keypad problem. So stick around. That's a pretty important problem that we're going to do as soon as possible once we are done with this code. So we just need to read a string in Java, and the moment we read the string, we just need to send it to a function called Lapindromes. So if the function returns 1, we say that it's a Lapindrome. If the function doesn't return 1, that is, on the other hand, it returns 0, we say that it's not a Lapindrome. So we're just going to send this to a function we'll call Lapindrome of string. And since it returns value, we can just check if Lapindrome of string, if it returns a non-zero value, which is considered to be true in programming languages, we can just print something like Lapindrome. Otherwise, we will just print, let's say, something like not Lapindrome. So that's exactly what we're doing, and we're just going to have a function called Lapindrome here, where we're going to read the string, which we're going to have to figure out if it is exactly a Lapindrome or not. So let's take a look at this very, very quickly. Now, we need to create an array of characters. We need to create an array of characters which is going to have 26 elements full of zeros. Now, to do it in a very quick and short method, I'm going to take all of these away, and I'm just going to show you one short method where we can create an array of 26 elements. So I'm just going to write here array equals 0 times 26, and I'll just print array, and we'll also print length of array. Now let's just see what exactly happens here. If I compile or interpret and run this, it gives me 26 values, and the length of it is 26. So what exactly has happened here? Just observe this. This is a list. Alright, so we are creating a list which only has a 0. Our list initially has just 1 0 and nothing else along with it. All that we are doing over here is just multiplying this list, multiplying this entire list of one single element 26 times. So it's going to create 26 more elements of the same and append to it. So it's just going to become an array or a list of 26 zeros. So we don't have to go through for loop and everything. This is a shortcut way for us to do this, where I'll just say array equals 0 times 26. So these are just a few shortcut methods which we have in every programming language. And the more we learn these things, the better it always is for us. Now let's go on for our program. Now remember, what did we do earlier on? We first figured out if our string is of length 0 or 1. If our string has a length 0 or 1, we are returning that 0 or 1 itself. So I'm going to take, let's say n equals length of string, so that we don't have to calculate it multiple times. If n is equal to 0 or n is equal to 1, we're just going to return n. That is done. Now on the other hand, if it's neither 0 nor 1, this is when we need to use a different scenario. This is when we need to use a different logic. Now here's the logic I'm going to do. Till now, the way we did this program was of a different logic, but now the way we're going to do this logic is going to be a slightly different logic. Now observe here, guys. All that we're going to do here is take a couple of examples so that we can understand how this is going to be solved. I'll take two scenarios, A, B, C. Okay, I'll just, yeah, let's say A, B, C and C, A, B. And the other one, I'll just take 4 characters. Let's take the same thing, Z, A, P and P, A, Z. So even this is even characters, so we didn't want to do that. So I'll just do something like A, B, C, D, C, B and A. Perfect. Now we have odd characters here and even characters here. Now I have one question. OR is typed as the word, not logical operator. Absolutely right. OR in Python is used as a word, not the logical operator. We're going to change that. Absolutely correct. That's right. So let's do that. I just wanted to ensure we got to know the difference very clearly. That's all right. Glad to hear one of you are already finding out these different things. Glad to hear you guys are already proficient with Python. That's a very good thing to always hear. Now what we're going to do here is, instead of slicing the list, we don't want to slice this string whatsoever. That's a possible value. That's a very simple way we can do this. Other way what we can do here is, we're going to create 2 pointers, I and j. I points to starting index, j points to ending index. What we're going to do here is, wherever we find a value in index I, we're going to go to our array. I hope you all remember from our previous video, we have an array full of zeros, which has 26 zeros. Something like this. And whose indices are, let's say, 0 up to 25. And what these represent is values like A, B, C, D and so on up to Z. This is what they represent. Now all that we are doing here is a pretty simple task. We're taking whatever is in index A, index I. For that index, we're going to increase the count by 1. And whatever is in index J, for that, we're going to decrease the count by 1. Then we'll increase I and decrease J. So I points here, J points here. Then again, we're going to do the same thing. For I will increase, for J will decrease. Then we'll increase I and decrease J. I points here, J points here. Then we do the same thing. Then increase I, decrease J. Then do the same thing. Then increase I, decrease J. Now J becomes lesser than I. When J becomes lesser than I, we know we have crossed half of the string. We don't need to do further on. That's when we stop. Similarly, for odd string also we do the same thing. I is here, J is here. For index I will increase the count. For index J will decrease the count. Likewise, we'll increase I and decrease J. Same thing. For I will increase, for J will decrease. Same way. For index I will increase, for index J will decrease. And again, for index I will increase, for index J will decrease. In this scenario, I becomes equal to J. Now, we shouldn't do anything when I is equal to J, because it's the same character. It doesn't really make a difference. So we can give a certain condition like while I is less than J, only while I is less than J, we will perform these operations. When I is either equal to J, that is we reach the middle character, or I becomes greater than J. that is in this case. That's where we exactly stop. So our condition is as long as pointer I is lesser than the pointer variable or not actual pointer. This pointer is because it is pointing to an index. When this pointing variable I is less than pointing variable j, less than, only then we'll perform this operation. So for every index of I will increase, for every index of j will decrease. Why are we doing this? Because we are still needing to ensure that our program will be done in big O of n by 2 plus 26 instead of n plus 26. We want to reduce the time complexity as much as possible. For that purpose, we are doing this. So let's give this a try. Let's see what happens and how exactly this works out. So I'm going to write here I equals 0 and j equals n minus 1. So that j indicates the last index and I indicates the first index. Now, as long as I is less than j, we're going to have to repeat these steps. As long as I is less than j, we're going to repeat these particular steps, where for the first part we're going to need to increase, for the second part we're going to have to decrease. Now here's where we start to find it a little difficult. See guys, if this is I, what do I need to do? Remember, I need to get the ASCII value of string 1 or string of I. Whatever is string of I need to get its ASCII value. After getting its ASCII value 97, I need to subtract it with ASCII value of A itself, which is going to be again 97. Once I subtract this will be my index of array. That's exactly what I'm supposed to do. So to access the index of A, here I need to take array of something. So that this, whatever I write here, will give us the index 0 for A. To do that, I need to take ASCII value of string of I. I cannot write string of I minus 97. This is not possible. This is not possible in Python. We need to do something else. See, to do this, we have a couple of functions. For those who may not be familiar with this, we should know this very well, especially when we commonly work with Python. There's a function called ORD and there's a function called CHR. In ORD function, whenever you give a character, it's gonna return ASCII value of it. In CHR, whenever you give ASCII value, it's gonna give the character version of it. So we'll just give it a check just to see. I'm gonna print ORD of A, and here I'm gonna print CHR of 97. So first statement should print for us the ASCII value of A, which is 97. Second statement should print for us the character value for this ASCII number 97, which is supposed to be A. That's exactly what we got. So remember, in Python, ORD gives you the ASCII value, CHR will give you character for an ASCII value. So let's go ahead and do this. So here, all that we need to do is for index I, for array of string of I. Again, I cannot use string of I need to convert it to its ASCII number. So to do that, I need to do ORD of string of I need to subtract 97. When this index comes, I have to increase it. But I cannot use plus plus, because remember, in Python, you don't have a pre-increment, post-increment, pre-decrement, post-increment. No plus plus minus minus statements are available in Python. So we need to find a different way to do this. We need to find a different way to perform the same thing. That is, we're gonna have to use plus equals 1 instead. Similarly, for the next one, let's say for the next scenario, we're gonna have to do the exact same thing. Hold on. Yeah. Similarly, for the next scenario, we're gonna have to do the exact same thing here. That is array of the index is ORD of string of j minus 97. We're gonna decrease by 1. That's it. Once this is done, we have to then increase the I value and decrease the j value manually. So all we're gonna do here is I plus equals 1 and then j minus equals 1. That's it. sorry, j minus equals 1. So whatever we had in the while loop earlier on, whatever we had in the for loop earlier on, where we are increasing I and j with a comma, since these operators are not available, we're just doing it like this. And that's it. So even here you can remove certain values. Even here, if you want, you can remove the requirement of mid by taking j equals length minus 1 and doing the same condition as we did here. So there's a lot of different updations we can keep working on, we can keep doing every time we go through these programs, so that we can observe and understand how better we can do this by reducing the requirements. Now, here's the thing, guys. Once this is done, we need to check if there is any value which is non-zero. I'll repeat, we need to check if there's any value which is non-zero in our array. If there is any value which is non-zero, that means it, of course, is not correct. So all we're going to do here is for I in range of 0 to 26, that is from index 0 to index 25, if array of I is not equal to 0. Again, remember, it is not equal to 0, then we'll just state return 0, indicating that it's not a Lapindrome. Otherwise, if it goes through successfully, we have already done this, we're going to return 0. Now, one thing I'm just going to point out, this should be our simple program. Let's see if it works. So we have done this in the most efficient way possible. Let's try to run this. Now there's one little error. I have missed out colon over here. Let's update that because we've just changed to Python. So when we go through different languages, there's a possibility that this may happen sometimes. So let's see where we have else over here somewhere. Yeah, here it is. We haven't used colon here as well. Let's update that. So let's try to interpret this. I'm gonna give a string like A, B, C, D, C, A, B. This is supposed to be a Lapindrome. Now, does it say that it's a Lapindrome? It doesn't. So somewhere we went wrong, right? Now observe this. Our logic seems to be right. If you remember, while I less than j, for I we increase, for j we decrease and everything. Now, somewhere we went wrong. Somewhere it's returning 0 over here. Let's say for even numbers also. Let's get to see. And this is how when we look at these problems like this, we'll get to see how to debug them as well. That's our main intention. So I'm gonna just give one more value, like ZAAP, PAZA. This is also supposed to be a Lapindrome. It says it's not a Lapindrome even here. If I don't give a Lapindrome, like let's say pizza, even that's not a Lapindrome. For every value, I'm getting not a Lapindrome. So why would that be the scenario? To understand this better, let's debug by printing array of I on the screen. We're going to print each array of I, each value array of I, and end will be something like /t, so that all of them will be printed same lines and everything. So let's see what exactly happens here. So when we run this now, if I give A, B, C, D, C, A, B, you get to see all of them are zeros. Now if you observe, all of them are entirely zeros, no doubt about it. That's pretty obvious and clear. So you can get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 plus 11, 22, 22 plus 4, 26 values, all are zeros. So if all are zeros, it's not going to return 0, it's going to go here. But what have we done here? Observe this, guys. What have we done here? Little problem. Can you guys help me out? If it's a palindrome, what are we supposed to return? Think of the code. For each array value, if any of them are non-zero, that means it's not a palindrome. That's why we return 0, indicating it's not a palindrome. But when the for loop is executed successfully, it goes to the next line over here. That means it's supposed to be a palindrome. If it is a palindrome, what are we supposed to return? Same value 0 or something else? 1, right? Absolutely right. So that's the little change. That's the small difference that we needed to do. Let's try this out. I'll take A, B, C, D, C, A, B over here. It says it's a Lapindrome. I'll take the same scenario. Let's say Z, A, A, P, and P, A, Z, A. Let's say it's also Lapindrome. Let's try the last one. We'll take something like pizza, which is not a Lapindrome. It says it's not a Lapindrome because A is present one times at the end. A value becomes -1, so it immediately stops. So this is your code to find out if a string is Lapindrome or not in the least time complexity possible. So this was the challenge for last night that I gave you guys to convert it to Python, which we just completed. So this is our entire program for Lapindromes in Python. Now, once we are done with the Lapindrome problem, let's quickly go ahead to the next one. So I'm just gonna write again, since I want all of you to have all the programs together as well. I'm just gonna write today's date over here, so that if you're searching for any particular video, if you're watching any video later on as well, you can just search for the date in the file and get the content right away of that date. So we're gonna move ahead here now from this. If you have any questions, any doubts in this program till here, you can feel free to ask. I will ensure to answer the same for you guys. Any doubt that you may have in this program, you can feel free to ask. But if it's been very clear, very easy for you to understand, then don't worry. Let's go ahead quickly over to the next problem. So the next problem we're going to take a look at is based on T9 keypad. So for this purpose, I'm going to need to take an image of a T9 keypad. So let's just take a T9 keypad image, which is going to be required for us. I think we can take any one of these. This seems good enough. Let's take this. Now, here's our entire problem. Here's our question. Now, this is our next question that we are working on. All right. So this particular question is based on strings, and you can expect such questions often on a medium level, medium to slightly difficult, medium to very slightly difficult, not the easy part. So if you get two questions, one you may be able to solve it in 10 minutes, other you may be able to solve it in 20 or 30 or 40 minutes. This could fall in such a category. So many of you may not remember T9 keypads because we are more familiar with QWERTY keypad even in phones, but there was a time back in the days where this existed. And those who are familiar with this, those who remember this very well, you guys can just give a shout out in chat so I can get to know if you're familiar with this. So I can get to know. So if you guys are familiar with this, or it's like alien technology for you guys. So you guys can let me know just by one shout out in the live chat. Now let's go ahead with this. Here, forget 1, forget star, 0 and hash. The problem deals with only 2 to 9. That is, if user enters 2, just remember this, if user enters, let's say, the digit 2 here. I have one question before going ahead. There is the last value. Okay, right. What is the time complexity if you use list slicing? See, I did not answer that. Very, very sorry. I think I wasn't able to see the chat properly over there. So there's one question that I've received. What is the time complexity if you use list slicing? See, when you use list slicing, what do you mean by this? You're stating that you're slicing and dividing your list into 2, right? Even then, the time complexity is same because you're comparing this to this. But the difference is your space complexity increases. If you slice it and store it separately, your space complexity increases. That's it. If you have a string and you slice it and store it separately, your space complexity increases. That's the only difference. So, so many of us are 90s kids, right? So we remember it. So glad to see that. Alright, so glad that you guys remember these sort of nostalgic memories. Now, let's go ahead here and let's quickly go ahead. I'm just gonna remove this we don't need, and this is our problem. So the problem is a very simple one, very simple one. If I type, yeah, old phones, right, Nokia phones, right. So if I type, let's say 2 on the screen, what are the possible characters that I could print? A, B, C. So that is supposed to be the output. Similarly, if I type 2, 8, depending on how many times I press it, it could be anything. If the order of typing is 2, 8, if I keep pressing 2, if I just press 2 and leave it, it's just going to type A. But if I keep pressing the button 2, it switches from A on the screen to B after a second, and on the screen is going to switch to C after one more second. So depending on how long we press, the key different character may appear. Now the question is that if I press 2 followed by 8, what are the possible characters that could print on the screen? That is what we need to print. We need to print that it can print AT, AU, AB, BT, BU, BV, and then CT, and then CU, and then CV. This is what we need to print. Similarly, if the input is a different number, let's say if the input number is something like, let me just take this scenario, 258, then you have 27 possible values. You need to print all 27 in its ascending order. That is the entire question. So in this case, you may have, when it's 258, it is A, J, let's say AK, AL, and AT, AU, AV, and so on and so on and so on. So one of the questions that was given here was that, I'll just point it out, you can print it in any order possible, but it should print exactly those 27 values only. That is the whole idea. Let's see if we can possibly do that. So if I just type 2, there are 3 possible values, A, B, and C. If I type 5, 2, 5, there's 3 times 3, 9 possible values. If I type 2, 5, 8, there is 3 times 3 times 3, 27 possible values, and so on. So all of them have 3 values except 7 and 9, which have 4 values each. So this is your entire question. This is your entire problem. So I'll just state, you're going to receive a string, or you can receive it either as integer. That's up to you, because we can read it either as a string or an integer. It makes sense for us to read it as a string rather than an integer. I'll tell you guys why later on. Right. So once we read this, we need to return all possible letter combinations. The returned answer can be in any order. It's immaterial. It can be in any order. They will check all the different values in the order. And whatever values are returned should be in new lines. They should be in different lines. That's all that matters. The output should be in different lines. So let's give this a try over here. Now, T9 keyboard problem. That is, I'll just write the question very quickly under a minute. So, given an input from combinations of 2 to 8, print the possible combinations of outputs in any order. That's it. This is what we need to do. So yes, we need to go through something called permutations over here. And for us to do permutations, we're going to use a couple of different, let's say, I would say we're going to use a couple of different data structures. Particularly here, we're going to use the data structure called Q. So first, let me explain how exactly we're going to solve this. Then we're going to, of course, solve it. So let's close this and let's give this a try. Now, let's take this scenario. Let's say I have 2, 8 as my input. Now, I need to create a data first, right? I need to create an array first, which is going to have these values. So I'm going to create an array of 10 values, 0, 1, 2, 3, 4, 5, up to 9. So 0 and 1 can store anything, it doesn't matter, we're just going to leave it empty, or we're just going to store something like A and A. From 2, here's what I'm going to store. If I type 2, remember this is an array of strings. This is an array of strings. From 2 to 9, I'm going to store the values like index 2. If user is pressing 2, I need to remember it should return ABC. If user is pressing 3, it should have DEF. If 4, it should have GHI. If 5, it should have JKL. If 9, it should have W, X, Y, and Z. So I'm going to store this in a separate array so that I can keep a track of this. I can keep a track of this for every value possible. So that's exactly what we're going to do. So in this scenario, from 2 to 3 to 4 to 5 up to 9, we're going to keep this order. We're going to keep the order of the values here so that we can remember which one, which number will print what, and so on. Now comes the question. Okay, somehow we did this. Fine, that's all right. But how am I going to do this? How am I going to solve this? How will I make sure that I get all the permutations? Now remember, since you're getting permutations, the moment you see permutations, you can immediately realize it cannot be big of n or big of n log n or something like that. It must be much greater. It becomes to the square, to cube, and everything. This is what we get to know. I have one question. How do we get to know if we have to use q here? Right. Very logical question. I'll answer that. See, whenever we go for permutations, we need previous data to calculate next data, right? We need previous data in order to calculate next data. Think of this. If I have A, B, C, and D, E, F, I'm going to have to use them to calculate next data like A, D, A, E, A, F, and everything like that. So for this purpose, I need to store them sequentially. And I'll just give you a better clue. Let's say it is 2, 5, and 8. So that you can understand why we use a queue. So guys, since it is 2, 5, and 8, here's what I'm going to do. I'm going to start with the first value, one at a time. So what I'll do here is, in the queue, please note and observe this, in the queue, I'll immediately store or initially store only what is represented by 2. Now what is represented by 2? A, B, and C. I'll store this. Then in the queue, I'll store the next one. What is the next one? 5. What is represented by 5? JKL. I'll store JKL. The moment I've stored this, I need to multiply them. I need to find all possible combinations of them. So what I'm going to do here is, I need to find combinations of A multiplied by everything, then B multiplied by everything, then C multiplied by everything. I need to find combinations of all of these. So all I'm going to do here is, in this scenario, I'm going to take A and I'm going to multiply with J, K, and L. So, and whatever results come, I will store in my queue. I'll get AJ, AK, AL. Once this is done, I'm going to delete A. Done. After that, then I need to multiply B with everything. So I'll also do the same thing with B. Let's multiply with everything. And I'm going to delete B as well. Then let's multiply the next one with C. When you multiply it with C, we'll get after this C, J, C, K, and C, L. That's also done. Then I'm going to delete C. Remember, I'm deleting one element at a time. When am I deleting that element at a time? After multiplying with its next 3 elements. I need to remember that I should multiply with only 3 elements, because other elements will also be created, right? I need to keep a track of this size separately. That is one thing we need to do. So once this is done, then we need to figure out how many elements are there and print all the elements which are of the size as of this. So how many characters are we, how many letters are we typing? 3. Are there anything with 3 letter length? No, they are not. So let's not print anything. Let's not do anything. So after this, what's the next thing? We're supposed to take 8. So we're going to take the 8th one, whatever it is, like for example, it becomes TUV. We need to store TUV before this. Very sorry guys. We need to store TUV before this. We're going to take TUV and multiply with all of these. So it becomes T is multiplied with all of them, then U is multiplied with all of them, then V is multiplied with all of them. So we need to multiply each one with the further values and store them over here. That is the basic logic. Alright, I've just given you the basic logic. Now don't worry, I'm going to go ahead and explain this in detail once to you simultaneously as we do the code, so that we can save time and do both simultaneously. Not to worry, I'll explain the logic as well as this. So the first thing is we're going to get a string. We're going to read a string. So let's go ahead here and start with this. I'm going to include string. I'm also going to include, let's say, q, because we're going to also need to use that. So the first thing I'm going to do here, as simple, is create a main function where we read a string. I'm going to take a string called str. We're going to read the string. That's it. This work is done. Once this is done, we're just going to have to call the function. Now remember, like call the function as phone permutations, phone perm, I'll just call it as, and I'll send the string, or we can call it as anything you want, like T9 permutation, anything you want, completely up to you, of the string. That's it, and we'll just return 0. So in this T9 permutation function, again, just to point out, if in interview they ask half the question and they want you to solve the other half, that is, they're asking half the question where they have already solved, let's say, the part where the main function and all are there, and they're only giving you the function to write. Apart from function, there's nothing else for you to edit. So in that case, half the function will be given to you, that is the skeleton of the function, and you need to solve the rest of it. That is, we're going to take something like void T9 permutation of string str, and that's it. And you would need to write everything over here. Now, here's the first simple logic that I'm going to show you guys. I'm going to take only two characters or two numbers to show the initial logic. We'll take 2 and 8. Let's say, for example. Now here, first thing I'm going to do is store my queue with an empty string, because it's a recursive loop. It's basically a recursion. It's a loop. All right. Since we are doing a loop, because 2, whatever is there, multiply with 8, then multiply with something else, we have to multiply one at a time like this. So since it's going to be a loop, there must be something initially to multiply with the values of 2. So initially I need empty string to multiply with the next value. To make sure I have empty string, I'm going to just say initially this queue is going to have an empty string. That means it's going to have nothing in it. Absolutely nothing. So that's what we'll have here first. Now, the first thing I'm going to do, very simple logic. Please note this, guys. Very, very simple logic. We're going to go through for each character. We're going to have to go through for every single character we have here. And for each character that we have to first take all the elements of the character and multiply with whatever we have in the queue first. Now, what do we have in the queue first? Let's remember this. What do we have in queue first? It's a space. What is the size of the queue? Our queue size is 1. We have to remember this. I'll tell you why exactly this is important. Because if we don't remember this, our output will get repetitive, recursive, and it won't be in the order that we want it to be. It's gonna go all random and haphazard. So our queue size is 1. So for this one element, whatever is the first index, remember, for each index we need to repeat these steps. We're taking the first index. First index is 2. What does 2 indicate? A, B, C. Since 2 indicates A, B, C, we're going to take whatever is in the queue, remember the size of it, and multiply whatever is in the queue one character at a time with this. So there's only one character here. Since there's only one character here, we're going to multiply empty string with A, B, C. We're going to get A, B, C itself. We're going to add them. We're going to get A, B, C itself. Once we have done this, since we have multiplied this empty string with everything, we are going to remove it. because it's no longer required for us. We're just gonna remove it at the end. It's not required for us whatsoever. We'll be ending up with only A, B, C. So this is how we get the first values. This is how we get, let's say, the first um, index or the first character values over here. Then once this is done, let's go for the second index, second character. Once we go for the second character, we're going to repeat the same steps. Let's go to second character. What does it indicate? 8. So what's the value we have in 8? These three, T, U and V. Now, since we have T, U and V over here, let's take a look at the size of the queue. The size of the queue is 3. So that means I have to take each one of these characters. I have to take each one of these characters, A, B and C, and multiply with TUV. So let's do that. I'm taking A and multiplying with all of these first. So I'll get AT, AU and AV. Then we'll take B again. I'll get BT. Again, before taking B, since I've multiplied A with all the characters, I'm deleting A from my queue. That's it. Its work is done. Now, once this is done, let's go to the, let's remember the size of the queue. Size of the queue was till 3. So we should only do till 3 elements. We should only repeat it 3 times. That is for A, B and C. We shouldn't repeat 4th time by having AT multiply the rest of the things or AT multiply TOV again. Then our logic becomes wrong. Please remember that. That's why I'm keeping queue size in prior, because our queue will increase in size. I'm keeping it separately. So once I do this, let's multiply B with everything. I'll get BT, BU and BV. That's also done. So I'll just draw the lines here so that we can differentiate. Once this is done, I'm going to delete B as well from my queue. That is done. So once that is done, this is what I'll have left. Now remember, out of the 3 values that we wanted to multiply with, we only have 1 value remaining. So that 1 value, whatever we have remaining, C, we have to multiply that with everything as well. So we're going to get C multiplied by, again, the same thing, CT, CU and CV. So this is the output that we get. And then we're just going to delete C. That's it. This is our end of the function. Now, in case there was one more digit here, like 5, then all of these should be multiplied with 5 again. That is, if there was one more digit, let's say 5 here, then we're going to have to take 5, mark it, and we're going to have to take each one of these and multiply with 5. That is ATJ, ATK, ATL, then AUJ, AUK, AUL, and then AVJ, AVK, AVL, and everything. So after multiplying with each one, we have to remove them how many times? Total 9 times, remembering the size. Then at the end, we'll have 27 3-letter character combinations. That's how we're going to create it. So this is how it's going to work. Now, I have one question. The queue should be dynamic, right? Absolutely right. So it doesn't necessarily have to be dynamic. Here's the problem. You're creating a queue of strings. Now, when you create a queue of strings, you can either do one thing by calculating the size beforehand. It has to be dynamic mostly, yes, but one more thing you can do is, since there are 3 characters, observe this, 2 times 8 times 5. How many values do you need at maximum? 27. With that 27, you may need to store previous values along with it as well. So we don't know exactly how long it may take. Calculating this takes more time. So we have this concept called queue, which can be dynamic in size. So that's exactly what we're going to use. We're not even going to worry about what should be the size limit. We're just going to use a dynamic queue of strings in this logic. So this is the entire logic. Now I hope everyone joining in the live chat for this session, and just to point out, this isn't just a YouTube video which you can only watch and not ask questions when you have doubts or something like that. We have a very interactive session here, so that any doubts that you may have, you can feel free to ask as well, which we will ensure to answer and go through. So if you feel like you have certain questions on this problem, feel free to ask. And this is like a very unique thing of our live sessions on YouTube that we have for you guys. So I have one question: should we change the queue size before multiplying the third number? See, here's the thing. Before multiplying the third number, you need to keep a copy of the size of the queue. What's the current size of the queue? It's 9 elements. So you need to keep a copy of the queue size as 9. So you have to repeat this step exactly 9 times, not more than that. If you repeat it more than that, then the value you get here is ATJ. That will be multiplied by everything, and we get 4 length characters as well, which is not required according to our scenario. So that's something we need to always note and remember. So I hope this idea of the program is very clear. Don't worry about time complexity and everything. I hope at least the idea of the program is clear. I hope the logic of the program is clear so far. You guys can just give a message in the live chat stating that whether you're able to understand this, or if it's a little bit confusing. I hope it's a pretty simple enough logic that we're able to understand. So not too difficult, I hope and assume. So let's start with the first scenario and how to solve this in that case. So we're going to take here. Now, one of the first scenarios, what if the length of the string is 0, as always? If you're only supposed to fill this function and some string is given, what if the length of the string is supposed to be 0? I have one question: where those permitted elements will be stored? They're stored in this queue only. In this queue itself, we extend the size and we keep storing it. So we don't store it somewhere else. We are using the queue itself to store initial elements, then multiply, then store next elements. Every time I store next elements, I delete only first element. Since I'm deleting only first element every time, it makes sense to make it a queue. Because in queue, if you remember, deleting and inserting is time efficient. If I take an array, if I take a regular array, arrays are not circular. Since arrays are not circular, if I delete one element, all the other elements should be swapped by one index. That is going to take a lot of time. Remember guys, here's the main difference between arrays and queues. If I have an array 1, 2, 3, 4 and 5, if I delete one, that means I have to move all the elements over here. That's going to take a lot of time. On the other hand, if you have a queue we generally point it as a circular queue, or we just say our index or pointer moves ahead, so which makes it a little easier. So with all these dynamic queue options, it makes it a little more easier. So let's go ahead. And if you really are interested in knowing more, one thing I would always suggest, whether we are experts at these languages or whether we are beginners at these languages, the official documentations of any language will always help us learn in detail and very well about all of this. So you can just search for queue within the official Microsoft C++ documents, where you can get to know as many details as possible. Like for example, what is the details, what are the different functions you have, how do they work, what are the features of the class. So everything can be learned. So it just tells you all the details, like how exactly it works. So this is something that can help you understand which data structure should be used when, and so on. So that always helps us out. So if anyone's interested in learning a lot more about, let's say, data structures, this official documentations are one of the best things for us to do. So let's quickly go ahead and take a look at the next thing. Let's try creating this logic. Now, the first thing I'm going to do here in our code is to create a string of T9 references. So I'm going to do something called string T9 of 10 is equal to, first I'm going to give empty string, and then I'm going to give empty string, because index 0 and 1, it really doesn't matter. I can just say they are empty strings in index 0 and 1. It really doesn't matter to me. For my easier understanding, I want to keep it 2 to 9 itself, because I don't want to confuse myself during coding. So I can take ABC for index 2, and then GEF, and then let's say GHI, and then JKL, and then MNO. Let's quickly do this. So let's just check once if you have done it right. So index 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we got it right. There's no problem with it. So let's just return first. If let's say str.length is equal to 0, you just return without printing anything. Or if they have particular scenario like invalid input or something like that, you can also do that. It purely depends on the interviewer. They may say if it's an invalid input, something print something like invalid input or something like that. So there may be different scenarios which you can easily write through. So we'll just leave that. We'll just go for anyway we know that right now. So we'll just go for the core code or the core concept for this. So we're gonna need a queue of strings. So let's take a queue of strings. Let's call this as string queue. Any name that you want to give, completely your choice. It really doesn't make much of a difference for us when we perform the programming. Now here's what we're gonna do. In this case, we're gonna initially have to push something empty. As you remember, initially when we write ABC here, if you guys remember, I had empty space or like an empty string. So that empty string will be multiplied with A, B, and C, so that it gives me A, B, and C. So for that purpose, my initial string will have string q dot insert of an empty string. That's it. We are inserting an empty string over here. Sorry guys, since we are in C++, I can't use insert. I have to use push. So for those who don't know, you can go ahead again back to the official documentation to just look at and learn what sort of functions are there in each of the data structures, so that you can find it easy. So over here, let's go ahead to the next part. Again, if you really want to go through functions, you can go through that. But since we are already familiar with this, I'm just going to write it directly. If you're interested, you can definitely go through the documentation. That'd be my suggestion. Now, I need to repeat this for each index of my string. So I'm going to repeat for I equals 0 and I less than string dot length I plus plus. That's it. Or if you want, you can even store int n equals string dot length and then just do I less than len or I less than n. It's completely up to our option. It's if you don't want the length of the string to be calculated again and again, you can just do this. Neither one makes much of a difference, but that's all right. So we also have to declare a variable called I for ourselves. So for each of the character, like for example, assume the string is 28. For each of the character, we need to find the possible characters in our string T9, our T9 table. So we have our T9 table where if str of 0 is 2, I need to go to the index 2 over here. That's what we need to do. So again, since these are characters, please remember str of 0, if I access it, it's going to give me 2 as a character. I need to convert this character to a number because I need to access 2 index over here. It's not a character, it's an integer index. So to convert this character to a number, here's what we're going to do. Remember, ASCII value of 0 to 9 as characters range from 48 to 57. So whatever character I want to convert, like if it is 2, if I want to convert to number, I'm just going to subtract it by 48. Let's see what happens here. Character 0 is 48, character 1 is 49, character 2 is 50. So all we are doing here is performing 50 minus 48, which is going to give us 2 again. So any numeric character we have, we can easily convert it by using minus 48. So I'm just going to use str of I minus 48. This will give me the actual value, and in this value I need to take this as index within T9. So T9 of whatever is string of I minus 48, string of I is 2, 2 as a character minus 48 will give me integer value 2. So once I get the integer value 2, that basically means I'm able to access, let's say whatever it is, and this whatever string I get, I'll call it as string current string. So I'll call this as current string. This is the current string I need to update here, because until I update here, this is going to be, just remember, as we have learned earlier, just an empty string. That's it. And the size of the queue also we need to store separately, because remember, every time it keeps increasing. So we can't dynamically calculate. We need to calculate it beforehand. So I'm going to also use queue.size. So I'll just write int current size, or you can just write something like queue size equals queue dot length. So that's all we're going to do. So very sorry, since this is queue, I need to use queue dot size, not length. It's not a string. So since we are currently working on strings, my mind was still in strings. So it's a queue. I need to use the functions for queue and not functions for strings. So in this case, I've taken queue size as 1. Remember, the queue size is 1 and current string is ABC. So we're going to have to multiply every element until we reach this queue size of the queue with this current string. And after multiplying each element, we need to remove that element from the queue as well. We need to do both of these steps. So let's do that. So how many times am I supposed to repeat this? As many times as there are, as many times as there is this size of queue is not empty. As long as this size of queue is not 0, I need to repeat this. So let's go ahead and do the simple logic, that is while, I'll just write this, while queue size. So this means while the previous elements of queue are not deleted. As long as they are not deleted, we need to repeat these steps. Now, what are the steps I need to repeat? I need to repeat each of these characters multiplied by current string. I need to multiply each of these characters with each of the character of current string. So if this is my first character, I need to multiply this with every character of current string. So I need to loop current string and multiply the first element, or add the first element for each element of current string. So I need to loop through current string here, because my current loop, remember, my current loop is through queue size. So if queue has 4 elements, it's going to loop 4 times. Once we loop 4 times, each of these 4 times we need to multiply with something, right? Whatever we are supposed to add it with or concatenate it with, I need to loop through this. For first element, I'm looping through this and adding. For second element, I'm looping through this and adding. For third element, I'm looping through this and adding. For fourth element, again, we're looping through current string and adding. So we need to loop through every character of current string now. So let us do that very quickly. So I'm going to write here again, we're going to declare one more value, j here, for, again, since it's declaration, if you really want, you can just write it before. It makes better sense for anyone to read and understand the program. For j equals 0, j less than current string dot size. So current string is a string, right? So dot length and j plus plus. We're going to go through each character of current string and we're going to add our frontmost queue element. Remember, we're going to add our frontmost queue element and append to it. So all I'm going to do here is I'm going to add frontmost queue element, that is queue dot front. When I use queue dot front, it will give me the frontmost element of the queue, but it will not pop it. Please remember, it will not remove it. It will only return it. It's not going to remove it. It will only return it. To remove it, I need to use pop function. So I'm going to take the current or frontmost element of the queue, and I'll add it with current string of j, because we are iterating through each value of current string. So here in our case, space is added with A, then space is added with B, then space is added with C. After adding for each time, what are we supposed to do? We're supposed to take the result back and store it in queue, right? Since we're supposed to take the result back and store it in queue, I'm gonna do this. I'm gonna take steer queue dot push. That's it. We're just taking the result back and storing it in the queue. That's all that we are doing. Nothing else. Done. Now, once this is done, once this entire for loop is done for each character, I'll write for each character of current string, append front of queue with it as prefix. So once this is done, the next thing is I need to remove the frontmost element. To remove the frontmost element, I just need to use string queue dot pop. This will remove the firstmost element, frontmost element. So once this is done, we have gone through first element. Now remember, we have gone through first element. What if there was one more element? Because our queue size currently is 1, so that's fine. What if our queue size was 3 here? What if, for example, we had A, B and C here, and we just multiplied A with these next 3 characters. Let's say we had something like T, U and V here. Let's say A is multiplied with T, U and V. We get AT, AU, AV. This is done. Once this is done, let's quickly close this. And we need to remove A. That is also done. So once this task is entirely done, then queue size, which was 3 previously, should become 2 now. It was initially 3 because we had 3 values. Now it should become 2. And for these 2 variables, we need to repeat it again. So for that purpose, I need to reduce queue size here. Queue underscore size minus minus. That's it. Once this is done, for as long as it is required, for each of the current string, for every single current string we get, if we keep repeating it until the queue is empty, until current string or until this value keeps going ahead and emptying, that is our entire logic. That's it. That's the whole scenario. So what we are doing here is, remember, first for each input number, we are taking or retrieve characters corresponding to the number. For each input number, we're going to retrieve characters corresponding to that number. And for all the characters, we're going to keep adding them and doing this. That's it. This is your entire logic. So if you find it a little difficult, if you find it a little confusing, please go through it, trace it out, debug it so that you can try to understand the entire program in detail and not find it difficult whatsoever. So once this is done, all we need to do is iterate the last elements of the queue, or all we need to do at the end here is just iterate, let's say, all the elements of the queue. So pretty simple to iterate. I need to print all the elements of queue from front to end, right? So all I'm going to do here is while, what's our queue name? String queue. String underscore queue. Sorry, string underscore queue is empty. It should be not empty. While the queue is not empty, all that we're going to do here is pop an element and print it. That's it. We're just going to use string queue dot front. We're going to print the frontmost element, end the line, then we're going to pop that. We're going to print each element and we're going to remove it. That's it. That's all we're doing. So this should print us the entire values. So let's see if it works. Let's compile this. and let's see if we have any errors in our code. Let's see. Okay, we are in the wrong directory, I think. This is okay. I think yeah, I was supposed to use code.cpp, not code.c, of course. And one more thing, I haven't used using namespace standard. Let's do that. Now let's try compiling this. There's one little thing where it says missing template arguments queue size. See guys, our queue name is not queue. Our queue name is string queue. We have made that one mistake over here. So we have solved that as well. So there's no errors. There could still be logical errors. We never know. Let's try running this. So let's try running this. So I'm going to give 2, 8 as my input. It's supposed to give me AT, AU, AV, BT, BU, BD, and CT, CU. Perfect. If I give just 2, it's going to give me ABC. If I similarly give 2, 5, 8, it's going to give me all 27 characters that can happen through this. So this is our entire program to print the possible characters that could be available, especially when you do this. So this is your entire program. That sounds simple and easy to work through. So I hope this was a very simple and easy program for all of you to understand. I hope it wasn't too difficult. We have used a slightly new data structure in our program today. That was that was queues in this case. So you guys can let me know over chat. You guys can let me know if you guys found this program now easy to work with, or if such permutation problems are asked, do you find it slightly easy or is still difficult? You guys can feel free to let me know. So it's always a good thing to hear from you guys regarding the same. So by the time, I'll just share the link for you guys. So glad to hear it's been useful for you guys. Very glad to hear. So let me just share the link very quickly. So glad to see that it's interesting as well. So we'll try to go through as many interesting problems like these. So very glad to hear such nice feedback as always. So do join for our next live session as well. Keep subscribed and go through the channel. We've got lots and lots of videos. And also do subscribe, and you guys can keep track of live sessions that will come up next as well, where you can keep a track of our next video. We're going to go through more programs on TCS Digital. We have our current program to be converted to Java and let's say Python as well, which we'll do very soon. And we'll catch up in the next session. Till then, have a good time, take care, and keep working hard and keep preparing hard, guys.